Module 3, Session 3, Fraction, Spin, and Add, and Line Plot Fractions. So today we will continue to look at the line plot data from Sessions 1 and 2, and then we're going to answer some questions about the data that involve fractions. I will tell you about a game as well. Unfortunately, though, we won't be able to play the game, but at least I can tell you about it so that you can be aware of what it is and what it's all about and all that kind of stuff, okay? So, and also, we will recognize and generate equivalent fractions. We will use a visual model to explain why a fraction is equivalent to another fraction, and we will convert a mixed number to a fraction and vice versa, okay? So I'm just getting something ready real quick here as we go. Okay, so if you could open up your student book to that same page that we were on the other day, I believe it's 237. Yeah, page 237. We're going to take a look at the completed line plot at the bottom of the page, and we're going to review median, mode, and range of the data displayed. Okay? All right, so the first question I want to ask you is, what fraction of the entire group of students were in the pool for 3/4 of an hour? All right, so when you think about this question, what fraction of the entire group of students were in the pool for 3/4 of an hour? Well, I want to give you a little refresher here that there are 24 students or kids. Okay, and we want to know what fraction of that entire group of students were in the pool for 3/4 of an hour. So basically, we're going to end up talking about two different fractions here. The amount of time the kids spent in the pool and the fraction of the total kids who were in the pool for that long. So there are two x's at 3/4, okay? So I'm going to highlight those two x's at 3/4 right there, okay? And there are 24 children. So that would be 2 out of those 24 children. So let's think about a fraction that is equivalent to 2/24. So if you have 2/24, so 2 students out of those 24 students were in the pool for 3/4 of an hour, okay? 2/24. Think of a fraction that's equivalent to that. I'll go back to that page for a second, sorry. So 2/24 is the same thing as 1/12, okay? So that means that either 2/24 or 1/12 of the students were in the pool for 3/4 of an hour. Okay, all right. Next question is, what fraction of the student group was in the pool for exactly 1.5 hours? 1.5 hours. Okay, so that fraction is right here. And we know that we have 24 students. And there are 1, 2, 3, 4, 5, 6. So 6 out of those 24 students were in the pool for exactly 1.5 hours. Okay? All right, so what fraction is equivalent to that? Well, we could say if I divided 6 by 2, that would be 3. And if I divided 24 by 2, that would be 12, so 3/12. Or I could divide 3 by 3, which would be 1, and 12 by 3, which would be 4. So that would be 1/4, right? Or I could divide them both by 3. So 6 divided by 3 is 2. 24 divided by 3 is 8. So look at all those different fractions that are equivalent to the number of students who were in the pool for 1.5 hours. So 6/24 is the same thing as 3/12, which is the same thing as 1/4, which is the same thing as 2/8. All right. Okay, and then the next question is, what fraction of the students were in the pool for at least 2 hours? So I'm going to go ahead and it doesn't let me, for whatever reason, it doesn't let me erase. I don't know why. Anyway, what fraction of the students were in the pool for at least 2 hours? So this means 2 hours or more. So I'm going to highlight with a different color here. So 2 hours, and these were more than 2 hours, okay? So if we look at our data here, we can see that 4 students of the 24 students were in the pool for 2 hours or more. And that is equivalent to, so 4 divided by 2 is 2, and 24 divided by 2 is 12. So either 2/12 or 4 divided by 4 is 1, and 24 divided by 4 is 6. So 4/24 is the same thing as 2/12 or 1/6 of the students were in the pool for 2 hours or more. Okay? All right. Moving on here. So I'm going to introduce the game that we were going to play, but we're not going to actually be able to play the game because, of course, you don't have the supplies and I don't have the supplies. So with this game, though, it's called Fraction, Spin, and Add. So with this game, players would take turns spinning a fractional spinner, and then they would add the fractions that they spun. Then they would find pattern blocks to represent their spins and place them on their record sheet. Okay, and then whenever possible, players would trade up pattern blocks so they always have the fewest blocks as possible on their sheet. So for example, let's say that you spun and it landed on 1/2, okay? And we know that the 1/2 of the thing would be the red trapezoid, right? So I might put a red trapezoid. And then my partner might take their turn. And then I would say, okay, all right, I spin again. And let's say I spun 1/6. And I know that the green, I know that the green triangle is the same thing as 1/6, okay? And then let's say that I spun 2/6, okay? And then you can see that I would have 2 more triangles, but I want to use the least amount of pattern blocks that I possibly can. So when I say trade them out, I would actually trade out these 3 triangles for 1 trapezoid is what I would mean by that, okay? So I want to use the least amount of pattern blocks as possible, whenever possible, okay? And then also, so players would continue to alternate taking turns spinning, adding, and then placing pattern blocks onto their paper until one player fills all 6 hexagons on the fraction spin and then add it to the record sheet. So this is totally a game that you could be playing with someone at home if you wanted to. You could just not have pattern blocks and simply draw on your things like I'm doing. So I'm going to take all these markings away. So in case you wanted to play the game with someone at home, you have this blank little sheet to do that if you wanted to, okay? And then here's an example of what the game might look like if we were able to play the actual game. So like I was talking about earlier, if you think about the actual hexagon, now we know that the hexagon in our classroom is yellow, okay? So if we think about that hexagon as one whole for a minute, okay? And then what fraction would the red trapezoid be? And I kind of gave you a little hint there. So the red trapezoid would be 1/2, right? What fraction would the blue rhombus be? Well, you can kind of see that I could fit 1, 2, and I could actually fit one more. So the rhombus would actually be 1/3 of the whole hexagon. And then what fraction would the green triangle be? Well, it takes 1, 2, 3, 4, 5, 6 of them to fit on the hexagon. So that would be 1/6, okay? So I'm going to kind of show you that a little bit differently here on the next slide. But think about these shapes and how they relate to each other as well. So that it's kind of interesting how our pattern blocks, we can talk about fractions with our pattern blocks, as well as what shape they are and all those kinds of things, and how you can fit them together to make one whole shape, okay? All right, so on the next slide here, you can see, so we're going to review the fractional values of each pattern block based on one hexagon being the unit of one whole. So like I was just saying a little while ago, the red trapezoid would represent 1/2 of the whole hexagon, and it takes 2 red trapezoids to cover the yellow hexagon, as you can see right here, okay? We can see that the blue rhombus is 1/3 of the hexagon, and it takes 3 of those blue rhombuses to cover the yellow hexagon, as you can see right here, okay? And you can see that the green triangle is 1/6 of the hexagon because it takes 6 of those green triangles to cover the yellow hexagon, okay? And then you can also see, if you look down at the bottom here, in this little part right here, you can see that you could take 1/2 plus 1/3 plus 1/6 to equal 1 whole, okay? You can take 1/2 plus 1/6 plus 1/6 plus 1/6 to equal 1 whole, okay? You can take 1/3 plus 1/3 plus 1/6 plus 1/6 to equal 1 whole, okay? And you can take 1/3 plus 1/6 plus 1/6 plus 1/6 plus 1/6 to also equal 1 whole. So it's really neat to see how our pattern blocks fit together like that, okay? And notice that I'm really only using the red, the blue, and the green. I'm not using the orange right now. I'm not using the light brown right now. I'm simply using the other 4, okay? All right, so if you could turn now to student book page 242 for me. So we're kind of moving down a little bit here. So this is the plain fraction spin and add sheet that goes with it. Now I know you may have been able to play the game, but you may not have, okay? So I'm just gonna pretend here and kind of do this page with you, and then I'll tell you what you're gonna do on your own, okay? So Melinda is playing fraction spin and add, and she spins 1/6 plus 2/3. So let's say that we've got our hexagon, and Melinda spins 1/6 and 2/3. Okay, so what is the sum of Melinda's spin? Okay, so if we've got 1/6 plus 2/3, I do know that I need to change and make sure that both of my fractions have the same denominator. Do you remember that? So I want to make them both have 6. So I'm going to keep my first one the same, 1/6, but I'm going to change the other one to have a denominator of 6. In order to get from 3 to 6, I need to multiply by 2, okay? So whatever I do to the bottom, I'm going to do the top. So 2 times 2 would be 4, okay? So then now I can add them together because I have the same denominator. I'm sure you probably remember this, okay? Now I can add them. So 1/6 plus 4/6 equals 5/6, okay? So that means that Melinda, the sum of her spin was 5/6, okay? Now, what pattern blocks should she put on her record sheet so that she uses the fewest pieces? Well, I would say, you see how I have those 2 blue rhombuses and I have 1 green? Well, that's using 3 pieces. Think about if there's any way that I could use just less than that. So I want you to look at it for a little bit. And if you look at it very carefully, I'm going to go ahead and draw it again. And I'm going to draw it a little bit smaller this time. Now, if you look super carefully, okay, what if I went like this? And I used one of these, okay, and one of those. Now I have only used 2 pieces. So I would say that Melinda should use 1 trapezoid and 1 rhombus. Okay, moving on to Kevin. So now it's Kevin's turn, and he spins 2/3 and 5/6. So what is the sum of Kevin's spins? Okay, so now we have 2/3 plus 5/6. Okay, well, I already know that the 5/6 is going to stay the same, right? Because we're going to make the denominator 6. But to make 2/3 equivalent to, or have the same denominator, I already know that 2/3 is going to be 4/6 because I did that one already, right? Okay, so now if I add them together, I have 9/6. Ooh, 9/6 is an improper fraction, but I know that 6 goes into 9 one whole time, and then I would have 3 left over, so it would be 1 3/6. So I could say it like that or I could say 1 1/2. Okay? Now, what pattern blocks should he put on his record sheet so that he uses the fewest pieces? Okay, so 1 1/2. Let's think about that for a second. To use the fewest pieces, and unfortunately I made my first hexagon too big. Whoopsies. Ignore that. Sorry, everyone. If I were him, I would use 1 whole hexagon, right? Because that would represent my 1 whole. Now think about what pattern block is half of a whole. That would be a trapezoid. And I know that my hexagon is not the exact same size because I couldn't fit it on the page. All right, so if I were Kevin, I would use 1 hexagon and 1 red trapezoid to use the least amount, okay? Now let's talk about Ryan and Elizabeth. They are also playing fraction, spin, and add. Ryan spins 1/2 and 2/3. Elizabeth spins 1/3 and 5/6. Who has the greater sum and how do you know? All right, well, let's add Ryan's up first. Ryan has 1/2 plus 2/3. Well, there's a 2 and a 3. I'm going to make both of them have a denominator of 6, okay? So to make 1/2 have a denominator of 6, it's going to be 3/6. And to make 2/3 have a denominator of 6, it's going to be 4/6, okay? When I add those together, 3 plus 4 is 7/6, which equals 1 1/6, okay? So that is Ryan's, and I will add up Elizabeth in a different color. Okay, so Elizabeth has, 1/3 and 5/6. 1/3 plus 5/6. Remember how we would always laugh about saying sixths? Bringing back memories, boys and girls. Okay, so 1/3, I'm going to make that have a denominator of 6. So 1/3 would be 2/6 plus 5/6. Oh, look at that. That equals 7/6, which is the same as 1 1/6. So, who has the greater sum? Neither. Their sums are equal. Okay. All right. So, I have done 1A, 1B, 2A, and 2B, and 3 with you. I would like for you to give number 4 and number 5 a try on your own, okay? I know you can do it. Just like I did, you can draw pictures, you can do some addition, you can even take a screenshot of my paper, or you should have this written on your paper anyway, okay? So I want you to finish number 4 and number 5, okay? But also, whoa, sorry, boys and girls. So number 4 and number 5 on student book page 242. And then you are going to do home connection page 125, which is bakery bundles. So Rachel owns a bakery and sells cookies by the dozen. She sold 16 dozen cookies on Monday. How many cookies did she sell? Show your work. So you're just going to practice with some word problems. For each dozen cookies, Rachel used 1 1/2 cups of milk. How many cups of milk did she use for 16 dozen cookies? Show your work. A customer ordered 28 cupcakes. What are all the different regular arrangements that Rachel could use to package the cupcakes? Use labeled sketches to show possible arrangements. And finally, Rachel's assistant says that 3/5, I think it says, cup oil is more than 2/3 of a cup oil. Is she correct? Explain your reasoning. So you're going to do that page. And you're also going to do home connection page 126, which is just a continuation. So again, you will complete page 242 in your student book, just 4 and 5, because we already did the other ones. Then page 125 in your home connection book, page 126 in your home connection book, and one final thing. You're going to choose one IXL lesson to complete anywhere between J1 and J5, okay? One IXL lesson, and that, boys and girls, is your lesson for today. Have a great rest of your day, and I'm super proud of you.